I was thumbing through one of the manuals. Of course, when I say thumbing, I mean I was hitting the keyboard with my fingers, but fingering it sounds a little suggestive. And I ran across a reference that you could make your own custom interrupts. I was like, oh, okay, that's interesting. And I thought of it, I was like, oh, it's kind of more of a novelty, because what could you do with a custom interrupt in your program that you couldn't do with just a subroutine or something? But then later I was thinking, well, if you're doing your own operating system, you could totally take advantage of making your own custom interrupts that you could call anywhere across your operating system from any program. So I could see that being handy. I know that DOS had a few custom interrupts in there that you could call and take advantage of that weren't generally available in other assembly programming languages, so kind of made it a little more attractive. Your what was it, 21H, your Swiss Army knife, if I got the number right. Yeah. So what I'd like to do then, here, let's go back a little bit here to AX and a value, I guess 6345. I don't care. And so we run this. It should. That's quick. Let's run it. Are we in test? Yeah. Okay. To print a value. Yeah. 6345. Great. Wonderful. Okay. So we got this cool subroutine that we've made here. All right. You can store all of that in an interrupt. This is so cool. So then, instead of calling your print decimal routine, you could just load a value and then, hang on 1 second, and then just call your custom interrupt, which would be like, let's say we go here, it would be int OX20. Yeah, that's all I would have to do, and it would do all of this if I turn this into an interrupt. So why don't we try that? This is so cool. I love this. Okay, so that part, I believe, needs to be before this part. You can't declare it all down here. So up here, actually, I think it needs to be before everything up here even. Let's get on with that. We're going to set up our interrupt handler like that. Okay. And first thing, we want to make sure that no interrupts are interfering with this process. So we'll clear the interrupts. And then at the end, I forget what STI is. It's return from this interrupt handler. So basic line, of course. How obvious. So then we want to take our code segment register value, CS, and store it into DS, essentially. Oops, into DS. Wow, that looks cool. And if it wasn't greater than, I could use that in my own programming language someday. So the way, unfortunately, we can't just go, can't just use move DCS. No, I got a conflict. So first we have to instead move into AX, into our, oops, keep doing that comma thing, into AX, into our accumulator, the value of CS, and then once that's in there, then we can put that AX into DS there. Okay. So now that that is established, let's see. So we're going to just move a word value into a place in your computer's memory. Unfortunately, this isn't the memory where, like, when you turn your computer off and then you come back and turn it back on, it's still available. You would have to load this at startup. So when your operating system loads, you would be putting these values in there and everything, and then as it continues to run, they would be available throughout your system. Pretty cool, huh? Okay, so the way that works is you take this value and you can basically say times 4. So like here I could go 20 times 4, and forget about it being hexed. That's just the rule of thumb, to simplify. 80 there, see. And that is my custom address in the computer's memory for setting this first integer value, and you have quite a few from 20 all the way up to FF, and each of them can store a pretty good size program. How many bytes is that? I forget. But yeah, you could stick like quite a routine in there, which we're about to do. Undo there. Okay. So let us finish here. So what we want to do then is define our custom interrupt, which is down here. I could just call it print decimal, but just to clarify, I'm going to say beginning here is our custom interrupt. There. Whoops. Custom underscore interrupt. Yeah. Okay. So, and then all the way down here at the bottom, let's see. Here's the very last thing we do, return back. We're going to add a special return which tells it to an interrupt return, which is I return. Yes, I do. And let's see. So now we have a value loaded in memory. Whoops, I'm sorry, I'm not 100% done there. Now that I've made my custom interrupt, I can call it here, move it. I'm going to take all this now, all the way down to here, starting from here, and store it in a memory location at this address. Okay, and there was one more line of this code. Let me just copy all this. So move word into CS, into our code segment register. Yeah. This will be add 2 more bytes to this in hex. Okay, there you go. Let's see what actually happens here. Cross your fingers. There. We have successfully created our own custom interrupt. Nifty, huh? So now, let's see. So that's it. Just this little bit sets it up. Nifty, yeah. And then you can call whatever, like this wasn't necessary. Even like I said, that's redundant now, but. Yeah, it's nice for a note. So there. Yeah. Okay. Custom interrupts. Just for quick clarification here. So remember the 20 times 4 rule, right? So let's say if I wanted to use this address now, then 21 times 4 would mean that this is now 84, see? And then you add 2 more to that for that, see? And you can, like I said, you can go all the way up to FF and define as many custom interrupts as you want.